Parts of an X-ray machine. William Coolidge in 1913 developed the first cathode X-ray tube, and this became a prototype for all modern X-ray tubes. Therefore, all medical and dental X-ray tubes are also called the Coolidge tube. It's made up of three components: the control panel, the extension or the suspension arm, and the tube head. Let us first discuss the control panel. It is controlled by the on and off switch and is plugged to an electrical outlet. It also has buttons to control the exposure, time, kilovoltage, and milliamperage that help regulate the X-ray beam. Next, we have the extension arm, also called the suspension arm, that suspends the X-ray tube head and houses all the electrical wires that extend from the control panel to the tube head. The third part is the tube head itself, which has different parts that serve different functions. Let us discuss these in depth. At the very center of the X-ray tube head lies the X-ray tube itself, the heart of the machine. Within it, high-speed electrons originating from the cathode hit the target anode to produce X-ray photons, or X radiation. However, not all X-rays created are equal. The high-energy ones contribute to the useful X-ray beam, while the low-energy photons are useless and expose the patient to unnecessary radiation. To protect the surrounding environment from these X-rays or leakage radiation, the X-ray tube is encased in a tightly sealed metal body, aptly named the metal housing. A fascinating fact to note here is that only 1% of the energy in the X-ray tube becomes actual X-rays. The other 99% is energy released in the form of heat. To prevent overheating, the tube head's metal housing is filled with insulating oil to absorb this heat. As we discussed, the X-ray tube generates unwanted low-energy X-rays alongside useful ones. To protect patients from unnecessary radiation, filters are incorporated into the tube head, which can be of two types: inherent and added. Inherent filters include the tube head seal made of aluminium or leaded glass, which not only seal the oil and allow X-rays out, but also provide inherent filtration. Additionally, the insulating oil acts as an inherent filter, absorbing heat as well as unwanted X-rays. Inherent filtration is approximately equivalent to 0.5 to 1 millimeter of aluminium. If needed, we can add aluminium discs in increments of 0.5 mm to the X-ray beam path for further filtration. This is called added filtration. Both inherent and added filters remove non-penetrating low-energy X-rays, resulting in a higher energy, more useful beam that reduces patient harm and skin exposure dose by up to 80%. Dental machines operating at or below 70 kVp require a minimum total filtration of 1.5 mm of aluminium thickness. Above 70 kVp requires a minimum total filtration of 2.5 mm of aluminium thickness. These values are regulated by the state and federal law in the USA. Alongside filters, another safety feature called a collimator helps protect patients from unnecessary radiation. This component restricts the size and shape of the X-ray beam, minimizing patient exposure. It is made up of a lead plate with a central hole that fits directly over the opening of the metal housing where the X-ray exits. Imagine it like a blindfold with a central hole, only allowing the light to pass through a specific area. Collimators can be fixed or adjustable. In dental X ray machines, we use fixed collimators, which can be rectangular or circular, depending on the shape of the hole. Rectangular collimators restrict the size of the X ray beam to an area slightly larger than a normal adult intraoral periapical film or a size 2 intraoral film, significantly reducing patient exposure. Circular collimators produce a cone shaped beam with a diameter of 2.75 inches, exceeding the size of two intraoral periapical films. This results in a larger exposed skin area, resulting in a higher skin dose for the patient. After traveling through the tube head, the X ray beam emerges through the position indicating device, or the PID. This extension of the tube head plays a crucial role in shaping and directing the X ray beam towards the specific area of interest on the patient's teeth, like a nozzle of the hose pipe controlling the direction and shape of the water flow. PIDs can be conical, rectangular, or round. However, to minimize scattered radiation and protect patients, lead lined rectangular and round PIDs are preferred. These come in two lengths: short, that is 8 inches, and long, that is 16 inches. Longer PIDs are better because they spread out the X ray beam less. Additionally, rectangular PIDs are preferred because they further minimize exposure. To power the X ray tube, transformers are housed within the tube head. These devices also adjust the voltage of the incoming electricity, ensuring efficiency for X ray production. They can be of three types: the step down transformer, the step up transformer, and the auto transformer. Further details about the X ray tube and transformers will be discussed in our subsequent videos. With that, we come to the end of this session. We hope you had fun learning with us.